PD, and that's how we'll address it throughout the course. And we said that when you talk about potential difference means, suppose this is a potential bar, so you have one point, say VA, and you have one point as VB. So the potential of VA is always higher and the potential of VB is lower. This is the potential bar, just to understand. So we say that the difference between 2 points, say suppose I have got 2 points A and B. Now this is how you need to see it. These are a little bit of, use your imagination. So I would say the potential at A is known as VA and the potential at B is known as VB, and all we are trying to find out is what is this difference. So the difference of potential between 2 points is said to be the amount of work done in bringing a unit positive charge or moving a unit positive charge between the 2 points, and that charge is, say, Q is said to be our test charge. Okay, this is something like, let's like that 1 teaspoon which you will always sip to see whether salt is okay in cooking or not. This is known as our test charge. So potential, everything will always happen from higher potential to lower potential. Okay, the charge, so if you have a charge out here Q will always flow from higher potential to lower potential. That's nature's rule. Always things happen, from higher to lower the thing will flow. But how do we measure what is this potential? It's something like, as I told you, if I want to do an arm twisting with you and I want to test how much is your strength, there is no meter available to test your arm strength. So what do? We make you fight with a pre-calibrated robot, and we set the robot to some strength, and we say if you are able to defeat the robot, the moment where you are just able to defeat the robot, that's, or you get defeated by the robot, is basically your strength. That's your last strength. So the amount, now what we'll do, we'll move this charge from this side to this side. Now that's not possible because the charge will like to move from, this is higher potential, this is lower potential. The charge will generally try to come from higher to lower, but you are trying to move it from lower to higher. So in order to do this, you have to do some work, and this work is an external work. So that is known as the potential difference. The potential difference is work external done to move a charge, test charge Q, from B to A. I mean, this is, I'm writing it in grade 12 format, okay, just to make you understand. Potential difference between 2 points is the external work done to move the external charge from a point B to a point A. Okay, work done to move this charge from B to A. So mathematically, how we will show it? Okay, just a minute. 1 minute. The potential difference is said to be the external work done to move this charge from B to A. So work done per unit charge, external work done to move the charge from B to A. So what is the unit of work? Joules. What is the unit of charge? Coulomb. And the unit of potential difference is volt. So volts is equal to joule over coulomb. Right? This was what we studied the other day as potential difference. And if we want to measure the potential at one point, say you want to measure what is the potential at A, then we change this B and we take the B to infinity. And we say that the potential at infinity is always taken as 0. Therefore, VB, what did you measure here? You measured here VA minus VB, which is your potential difference, right? So in this case, you want to measure the potential of A, and I told you in last class, we can never measure the potential of anything, whether a child or a point. You cannot measure potential. All you can always measure is difference. This child has huge potential. Why are you saying so? Compared to some child, there is no potential meter. So when you want to measure the potential of this body, you will again use the same principle. So like, what was this? This was VA minus VB. Now we want to apply the same thing. VA minus V infinity will be again work done in moving the charge from infinity to A divided by the value of the charge. And arbitrarily this has been assigned the value of 0. So it becomes VA minus 0 is equal to work done from infinity to A divided by the charge, or V at A is equal to work done in moving the charge from infinity to the point divided by the charge. That's all we studied in last class. So if we go for definitions, okay, I'll hold for 1-2 minutes, don't worry. if we go by definition, then how do you define potential difference? We say the potential difference between 2 points. Difference is always higher minus lower. Higher minus lower is the work done in moving a test charge from one point to the other. That is from the lower point to the higher point. Charge will never come this way. Charge will try to go this way. But it's like A has a lot of potential, so A charge will always go from higher to lower. The charge will go there. Now, yeah. So what do? You try to push the charge from this side and you want to see what is actually the potential. How do you test a spring? You try to push the spring and say, yeah, really the spring is stiff. So that's the way you measure. We can always measure potential difference, not potential, right? So the next point in your topic will be what is potential at a point. Okay, the next topic was, this was our topic 1, and our topic 2 was electric potential at a point. Electric potential at a point. Now, if you want to study good in grade 12, you should understand right from now, you cannot measure electric potential at a point. All you can measure is always a difference. So how do you measure the difference now? Instead of keeping the charge, moving the charge from B, you move the charge from infinity, because you have assumed that at infinity the potential is 0. At infinity the potential is 0. So your expression becomes same. You are doing VA minus VB, now you are doing VA minus V infinity, where V infinity has been given the value of 0. So if you make it 0, it becomes this. So what the unit here also comes as joules over coulomb, which is known as volt. My age is blah blah years. The difference between me and your age is also so many years. The unit doesn't change. Potential and potential difference. So what are the questions that we can get from here? CBSE questions. Define electric potential at a point. State its unit. The electric potential at a point is defined as the amount of work done to move a unit test charge from infinity to that point. And the unit of potential is volt, given by the expression 1 volt equal to 1 joule over 1 coulomb. They may also ask you define 1 volt. 1 volt is said to be the potential of a point if a work of 1 joule is spent or done to move a charge of 1 coulomb from infinity to that point. Next type of question, define potential difference between 2 points. Potential difference between 2 points is defined as the work done to move a test charge between the 2 points. That is from lower potential to higher potential. And then they may also ask you, define 1 volt in terms of potential difference. So we'll say the potential difference between 2 points is said to be 1 volt when a work of 1 joule is spent to move a test charge of 1 coulomb from one point to the other point. I rest myself if there is any question, anything so far. What did you study? Electric potential. क्या हो गया? जोश कम हो रहा है तुम्हारा? हाँ, नहीं तो starting है. अभी से जोश छोड़ दोगे तो कैसे चलेगा? So we studied about electric potential difference and electric potential, and all these the 2 terms that you studied, we will be dealing this term more, and this in your very colloquial language is known as voltage. When you say that there is a plug point in my house and the voltage is 240 volt, it actually tries to say that here the potential is 240 volt and some apparatus which you have not connected, it is at 0 volt. So the difference is 240 volt. So when you connect, 240 volts will run down from here to here.
So what if they're using a different apparatus? So the apparatus has to be...
Every apparatus, if not connected, is at 0 volt.
So the apparatus has to be compatible with the
With the voltage. It has to be not compatible. It should have the ability to absorb so much of potential. If not, it will blow up. It's like I have got 20 chapatis with me and I'll give you all 20 chapatis. Do you have the hunger to eat all 20? If you don't have, then we will see you bye-bye in a hospital. Okay, can I rub this? Okay, right. And so the golden rule is, whenever you come to a class, please revise the previous class. Things that you will be learning now are all alien for you, but alien can be friends if you pay respect to alien. That means to the content which is being taught today. Don't close the book immediately after the class thinking that life is cool. Life will become namcool. Okay. So next is measurement of electric potential. No, you cannot measure potential, you can only measure potential difference. So measurement of potential difference, that's our topic. How do we measure potential difference? Measurement of potential difference between 2 points. Okay, between 2 points. If you are a little bit familiar with plumbing, basics of plumbing, understanding these things becomes easy. Let's say okay, let's say this is my apartment, okay, and this is the inlet water line. However, in my guest bedroom or my guest bathroom, I find that I am not getting enough pressure. Okay, the water line does not have enough pressure on my guest bathroom. What will be your first way to check? I mean, what will you do? You'll first go to the other bathrooms, check if the other bathrooms are having good pressure. That means you will conclude that there's some problem in this particular bathroom. And if all the bathrooms are having feeble pressure, then all you would like to do is ask your neighbor now, right? Whether he is having pressure in this bathroom or not. So what is the common concept? A common header line will be coming. This will supply to the other unit also, another flat. Yes or no? Right? So indirectly what you are trying to measure is, you will try to measure what is the water pressure here and what is the water pressure here. If you do not get any difference, then you should not have any complaint. When you are having a complaint, there will be a difference. So how do you check pressure? You check pressure with the pressure gauge. So there are pressure gauges. If you fix the pressure gauge, like how do you understand whether your tire is inflated or needs more inflation? You take it to the fuel station and you connect the pressure gauge. So suppose a tire is supposed to have 36 psi. If it is having 24, then you will say, my tire needs more inflation. Okay, I need to put. So you need a pressure gauge. Similar concept is there in this thing also. When you want to measure the potential difference between 2 points, the device that you need is called a voltmeter. Not voltmeter, voltmeter. Voltmeter. Volt is after the name of Alexander Volta. In his respect, we have given the name volt. And voltmeter is a device used to measure the potential difference between 2 points. Okay? Now, the questions that you will get here is, how is it connected? How is it connected? You have to have some interest, otherwise your this chapter will become very Greek and Latin for you. How is it connected, and why is it so connected? These are the two questions we need to answer. First, we need to answer this one. How is it connected? Right. Any one of you who has some interest in electronics or some basic electrical projects, I mean, are you familiar in practical? Because tell me honestly, okay, don't remain silent, just tell me honestly, are you practically aware how to light a bulb if I give you battery, wires and bulb? Can you do that? If not, then I have to explain you in different manner. If you can, then I'll understand that you have the prelim knowledge of how to glow a bulb. Can you glow a bulb with a battery and wires? Yes or no? Okay, if you don't know, okay, right, fine. So understand it like this. In order to glow a bulb, okay, say suppose this is a bulb, okay, every bulb will have two terminals below it. All you should do is, you should be able to connect it to a battery, okay. This is a battery, and if you connect it in this manner, what we say, your bulb will glow. This is the basic way how to connect a bulb and a battery. So let's put this into a circuit diagram. Now you don't even know what is a circuit diagram. So let us understand how the circuit diagram looks like. That's why ask questions, don't remain silent. The Duracell that you get in the market, something like this. This is your Duracell, okay? The battery that you get. You call it a battery, but that's not battery. This is a cell. In physics, this is a cell. This side is the positive side. This side is the negative side. In our circuit diagram, we will represent it like this. Start writing. This is a bigger one, this is a smaller one. This is a symbol for a cell. cell. So this is the positive terminal, this is the negative. The bigger one is positive because this has higher potential. This is the side which is at higher potential, and the smaller one is at lower potential. So commercially available Duracells and all are 1.5 volt, means the potential difference between the two terminals is 1.5 volt. Okay, and the positive is at higher potential. So in other words, you can say that this terminal is actually at 0 volt and this terminal is at 1.5 volt. That's why the difference is 1.5 volt. Okay, understood? Okay, and a bulb is usually shown in this manner, and you can make like this. This is a bulb. Many books will, in Cambridge and all, they show a bulb like this also. Okay, but in CBSE we are more accustomed to use it in this manner, so use this manner. This is the symbol of a bulb, right? This is the symbol of a bulb. So let us try to, let's say we have got a torch at our home which has two cells. Combination of cells is known as a battery. So let's also draw the symbol for a battery. Battery. A battery is a combination of cell. So have you opened your remote controls and all? You will see two cells connected, right? Top to bottom. Let's see whether in this one, okay? Let's see this one. So how many of you can see? Can you see this remote? You have two cells, one here, right? Connected in a top to bottom manner. So that combination is called a battery. So if you see the remote that I tried to show you, it has got one cell and connected with another cell. So this is the negative, this is the positive, this is the negative, this is the positive. So if you want to show the battery in diagram, we will show it like this, right? Positive, negative, positive, negative. This is a battery.
So the remote which you showed us, is that a battery?
Yeah, the combination is called a battery. Two cells, the battery consists of two cells. Like if you go to McDonald's and all, they will use so many cylinders of LPG. They'll say we have a battery, LPG bank, LPG battery. So the battery means combination of same unit. So if I have 4 cylinders, I'll say I have a 4-cylinder battery. So we are using cells, so we call it battery, right? So let's take up a small torchlight and also get to know this also, the switch, which is also known as key. So this is a key. The key is shown in this manner, either like this or like this. This is called a closed key. Closed key. This is called a open key. In our language used at home, open key means off and closed key means on. Just think about it like a switch, like this. See, if you switch it on, tuck. When you do that tuck, the contact is made, right? And when you actually open key means the contact is open. Circuit is open. Circuit open means electric current will always flow in a circuit. If you open the circuit, the electric current will not flow, right? So let's design a torchlight first. Then only we'll understand all these things. Let's design our 2-battery torchlight. So we have a 2-cell torchlight that you buy from the market. Yeah, come again, Bitu. Yeah, key is also known as a switch. A switch is also known. Key is the lab language for a switch. In lab, we call it key. So let's see a two-cell torch. So the one that you actually get in market will be something like this. It will be a torch like this. Inside there will be 2 cells. Okay, there will be 2 cells which you put in this manner, and a switch will be here and a bulb will be here, which actually glows. We're trying to design this system and see the circuit diagram for it. So we should have a bulb. This is our bulb. This is our bulb. Okay, and the bulb will be connected via a key, which is the switch, and then we have our 2 cells. This is the simple diagram of this is 2 cells means 3 volt, 1.5 volt, 1.5 volt, 3 volts, and this is right now our bulb is actually in switched off mode. Okay, so suppose somebody switches on the torch I'm drawing that with red color. So when you switch it on, your position becomes this and the bulb starts to glow. समझ में आया? So this is the simplest diagram of a two-cell torch lamp. Circuit diagram. Got it? Fine. Okay. Very good. So let's now take each of the components outside. So the two cells, I bought them from the retail shop today. So I presume they are absolutely new, unused. Agreed? And they should have 1.5 volt each multiplied by 2. So I am having 3.0 volts. Agreed? After 4 or 5 days of using the torch, I find that the glow of my torch has become little bit fainter. Faint or dim. I'll not say dim, faint. So obviously the thought that comes to your mind is the batteries must have run down, or that's the language that we use. Battery khatam ho gaya. Batteries must have run down. So now since you are a student of physics, you want to ascertain whether it actually is that is the problem or not. So now what do you need? You basically want to measure the potential difference between these 2 points, A and B. When you bought the cell from the market, then the potential difference was stamped on it as 1.5 volt. And you believe, no, it's no more 1.5 volt each, it's something less. So what do? You now need a voltmeter. Okay, you'll bring a voltmeter. And now question comes, how will we connect this voltmeter? So the voltmeter will always be connected across the 2 points whose potential difference you want to measure. You want to measure the difference between A and B. So this is always connected. This is important. Across the points where the PD is to be measured. And suppose after measuring this is giving a reading of 2.2 volt. Therefore, you understand that yes, the batteries have run down. Right? The batteries. Suppose your clock is becoming slower. So a voltmeter is always connected across the 2 points. Across the 2 points where the PD is to be measured. Right? So let's connect our voltmeter. So our bulb is not glowing. So one of the ways to test it is this way also. Look, suppose our bulb is glowing dim. Now this bulb needs a voltage of at least 3 volts to glow brightly. The bulb is not glowing brightly. So what do? You will immediately connect a voltmeter here across the points. Always remember, across the point means whether the potential difference is 3 or not. And you find that the potential difference is coming 2.2 volt. So your doubt starts, these batteries are not performing well. Got it? Let's take a better example now. Okay, let's take a better example. Early morning, your dad wants to start the car and your car is not starting up. Okay, so a car battery usually has a voltage between the two terminals. Between the two terminals, a car has 12 volts. 12 volts should be minimum dead voltage between two terminals. And your car is not starting up. So you get to know that you need to jump the car now. But before that, you need to understand whether the car's battery is actually down or not. So what do? You bring a voltmeter and you connect it between the two terminals. Here is where you will connect your voltmeter. And then you check. You find that it is reading 11.10 volt. That means you are now sure that your battery has run down. You need to either charge the battery up or bring an auxiliary car and jump this car. That also we'll see. We'll see that also. That's cranking. Jumping is a different operation. Jumping means, we'll see that later on. Just hold on now a little bit. So have we first answered one question? How is a voltmeter connected? A voltmeter is always to be, these things come later in the chapter, but I don't know how CBSE designs their courses. If you don't understand this, how will you understand how the voltmeter is connected? A voltmeter is always connected. So the first answer that we have to our statement is, a voltmeter is connected across the points between whom the PD is to be measured. Right? Between, across, the word is across. Now let's see this across more nicely. Let me make that diagram once again. Okay. Now watch. This is my bulb, right? This is my key, and my key is right now in switched on position, okay, because I'll have to measure, and these are my cells, right? As per definition, the voltmeter will be connected. Suppose I want to measure between this point A and this point B. I want to find out what is the potential. So how will I connect the voltmeter? I will connect the voltmeter in this manner, right?
Current will keep flowing.
No, wait. Now this is called, the voltmeter is connected across. Now this pattern of connection is also known as parallel connection. Yes, sir. This is also known as parallel connection. Okay, this is known as parallel connection. If you don't understand these, then it will be difficult. Parallel means the voltmeter is exactly in parallel with the bulb. Exactly in parallel. This is called parallel. Now you will ask, what is parallel? So see, again opening the Pandora's box. Two ways you can connect devices in electricals. In an electrical circuit, again deviation. Electrical circuit, you will come across these two terms quite often. One is parallel and one is series. What is a parallel? First let us understand what is parallel. Suppose I have a device out here. This is a device. Parallel means another device which is connected exactly on top of it. Parallel. Okay? Series means the one that you used to do in your childhood days. Ringa ringa roses. All of you holding hands together and going like this. Ringa ringa roses. So another way I can connect. Let's say this is device D1 and D2. This is parallel. Series would be B1 is connected in this fashion and D2 is connected in this fashion. This is called a series combination. This is called a parallel combination. Please get this thing in your mind. Parallel means, I used to tell children in this manner, you know, kiddos, kindergarten students, children go to the assembly. So how do they go? Put hands on each other and they go in a line. This is a parallel combination. His left hand with my left hand, that is the shoulder to shoulder. Right hand with my right hand. The other one, left hand, left hand. They all go in this. That's a parallel combination. All the kiddos are parallel to each other. How do we go in series? Let's all of us hold hands and walk like this. My left hand, your right hand. My right hand, his or her left hand. And that's the way we go. Garland. Okay? Our voltmeter, our friend voltmeter is connected across. Means this is across. In many books you will find that they will write that a voltmeter is always connected in parallel. Nothing wrong. Across, another synonym is connected in parallel. Understood? Right. So let's revisit this circuit now. Okay, let's revisit this circuit. So what should we have in our mind? In order to measure the potential difference between 2 points, we need a device which is known as voltmeter. How is the voltmeter connected? The voltmeter is connected across the points between whom the PD is to be measured. So me as a person wants to measure the PD between A and B. So I connect a voltmeter across A and B. That means parallel to these 2 points. Understood? Now let's see what happens. Okay, though you have not studied electric current, but just have some common notion that electric current always flows from, what is current? Okay, just layman's language. Suppose this is the potential ladder. You have a point VA and you have VB, such that the potential of A is greater than the potential of B. Now if you have a charge, what do you think the charge will do? The charge will always come from higher potential to lower potential. If you have water at a height and you are standing below, you don't expect the water to rise up on its own. The water from top will fall on your head. Agreed? So from higher potential to lower potential, whenever charges flow, as I told you in the very first class, whenever charges flow, they constitute what is known as a current. So current always flows from higher potential to lower potential. My neighbor is cooking biryani and I'm hungry, nothing is being cooked in my house, so the fragrance will obviously come from his house to my house. That's current, right? So if you have a river which is flowing from a height to another height, what is the water current? The water current will be this way, the stream will be in this way, always from higher. So our electric current will be actually flowing in this way, higher potential to lower potential. Okay, before the voltmeter was connected, the electric current is flowing in this way, and this is what is known as a circuit, Formula 1 circuit. This is known as a circuit. The current has to flow and come back. If this continuous path is not met, the bulb will never get lighted. For the bulb to light up, this circuit has to be made. So what do you do when you switch off? You open this. We open this. So it can't go forward. फंस गया. Therefore, इसलिए off हो जाता है. Off means you have just opened the circuit. So we have closed the circuit.
सर्किट ये नहीं हो रहा है, बेस नहीं हो रहा है इलेक्ट्रिसिटी.
कैसे waste होगा? That's why the battery is not stopping, it's continuously connected. Why will it get wasted? And whatever is the energy that is being used to light the bulb. Now we have connected the voltmeter. Now the interesting thing happens. Suppose the charge is coming from here and it comes to this position. Now it has come into a dilemma. Should I go this way or should I go this way? Right? If the charge starts to go this way, then obviously the current in this path will fall down. Not stop, it will fall down. Use some basic common sense is required in physics. If a water is flowing in this way and you have got two outlets, the water will go into two outlets. It will get distributed. Maybe equally, may not be equally. But we wanted to measure the potential here, thinking that water is going through this way. We brought a device, and the device, rather than solving our problem, the water is flowing into the device. Then our whole objective is lost. Are you getting it? Pay interest in this. My job was to find the potential difference between these 2 points. Right?
Yes.
Under the condition when water is flowing through it. Agreed? Yes. I connected a device and I allowed water to come to this device. So the whole purpose gets defeated. But is there a way, any other way to do? No, there is no other way to do. So my mind starts thinking, let me connect in this way, but not allow the water to come here. I can do that. So all I need to do is that I need to place a barricade out here, no entry. Then my job is done. Then my job is done, right? So how do we address that? Why is it so connected? That's what I'm coming to. Why is it so connected? So whenever you see voltmeters, okay, I'm rubbing this part. Now yeah.
Voltmeters are used to check the
Voltage difference between,
voltage difference.
yes.
So sir, volt per भी यहाँ पे भी more हो रहा है ना, then how is it measuring the voltage?
Voltage, a voltmeter just measures the potential difference between these 2 points. Every point has got a different potential. You are watching the circuit like this. Watch this diagram. The current is flowing from here to here. There are different potential levels. I want to measure the potential between these two, right? So I have connected a voltmeter here. Now the problem is that once I connect it here, the current gets another path to go, which I don't want it to go. I say, look, the water should go through this bathroom. I just want to see what is the pressure at this bathroom. So if the water, instead of going to the bathroom, goes into this, then my purpose is defeated. So when we manufacture voltmeters, this is a block diagram for you to understand. What we do, we build them with very high resistance. Now this is the symbol of resistance. Resistance means one sort of obstruction to what? Coming current. So overall, when you see the voltmeter available in market, the device looks something like this. It is not just the meter. It has got a not resistance. We'll put an adjective, high resistance. And this high resistance is doing the work of the barricade, no entry. So now comes the question, what is a voltmeter? A voltmeter is a device used to measure the potential difference between 2 points. Anything specific about the voltmeter? Well, a voltmeter has very high resistance, and this resistance is, since it is already inside the device, we will call internal resistance. Internal resistance, and the internal resistance is high. A voltmeter has very high internal resistance. Why does a voltmeter have high internal resistance? Because the voltmeter should not allow any current to pass through it. Should not allow any current to pass through it. Then it is a neutral device. Now it will come and just test what is the potential difference. So think everything like plumbing. This is my bathroom tap. Water is flowing through it, but when I open the tap, I am not getting the exact amount of pressure. So I ask a plumber to come with a pressure gauge. He just connects the pressure gauge and he says, sir, in your that bathroom, the pressure is so and so. In this bathroom, it is at least 5 units less. But what if half of the water went inside his pressure gauge? Then the whole purpose is defeated. We want the same water to go through here. Therefore, pressure gauges are always designed with non-return valve. There will be no valve inside. It will not allow anything to go. So bring that to electricity now. When you have a voltmeter, you always have a checkpoint out here. And that checkpoint is the high resistance. Now what we do, now look at this big diagram. We'll draw it in this big diagram itself. Now I bring my voltmeter. Now this is my big voltmeter. This is my big voltmeter as I purchased from the market. And let's connect this voltmeter. Now I am connecting it to, say, this is my bulb. Just imagine that this is my bulb. Okay, this is my bulb. I have connected it here. And my bulb is being fed by Duracell batteries. Okay, they are being fed by. So let's look at the current's direction. Okay, how is the current? The current starts flowing from the positive side, goes here, then it has a choice to go either way. It goes this way. Let us assume it is going this way, this way, this way. Immediately here it starts getting no entry. No entry. Because it finds the barricade. So the current will never flow this side. So the because I have drawn a big diagram, so you are feeling as if it will go this way, it will not go. So the current keeps moving in its original circuit. Understood? So the questions that we can get in CBSE. Number one, what is the instrument used to measure the potential difference between 2 points? A voltmeter. Can you say something, state, illustrate, or they may say, give the important features of a voltmeter. A voltmeter is a device which is used to measure the potential difference between 2 points. It is always connected parallel or across the points. Where the? Across the points. Across means parallel. Parallel cannot be series, Arkirat. Parallel cannot be 2 or 2. Series is ringa roses. Series means you hold this way. You want to connect a voltmeter in series, then your voltmeter should be here. Ringa roses. You cannot connect it in this manner. In that case, the current is going. Voltmeter, and what will happen? The voltmeter has got a high resistance, so the circuit itself is broken.
It won't be able to go.
It won't be able to go. That's the way. ठीक है, interest लो, नहीं तो ये only studying the textbook will, you may fetch marks immediately, but in the long run you will forget everything. So we always connect it in parallel, or called across the 2 points. Another specific thing, a voltmeter has very high internal resistance. That is for the reason that current should not pass through the voltmeter. Current should not pass through the voltmeter. Got it? Clear? और कुछ नहीं पूछता है आपके CBSE में. Can I close this part? Any question from this part anyone would like to ask? You can ask. What is, as I rub, I'll keep on saying, the potential difference between 2 points can be measured using a device or an instrument called a voltmeter. A voltmeter is always connected in whatever I am saying. If you remember this much, also more than enough. A voltmeter is always connected in parallel or across the 2 points between which the potential difference is to be measured. A voltmeter inbuilt has a very high internal resistance such that it does not allow the circuit current to pass through it when it is connected in the circuit. in a parallel mode across the point where the potential difference is to be measured. Any questions? See, the one of the problem is that in physics, if you all remain, this is very weird. A physics class cannot happen without questions. Either you are understanding everything, which I would be very happy, or you are not understanding and suppressing your misunderstanding thinking. But because a physics class cannot be a silent class. 101 queries come up. I thought your light, no query. Reflection, no query. Refraction, I should be given a Nobel Prize in physics actually. Whenever I teach somebody, children have no queries. And these are some interesting things. I gave you a car example, how a car battery started, how a car battery's voltage is. So do you see voltmeters? What you see actually the guys bring are not voltmeters, they are multimeters. A multimeter works as a voltmeter, a meter, or a ohm meter also. It is one device which can work for 3-4 different type of meters based on the setting. It's like you know what is a monkey spanner? Monkey spanner is a spanner which is an adjustable spanner. With that spanner you can open nuts of any sizes. So a multimeter is like a monkey meter. It can actually become a voltmeter. It can actually become for measuring resistance. So our chapter started in this manner. After a small recap of whatever you have studied so far, your chapter started with the very grandmother level talk of what is a conductor, then what is an insulator. Okay, these two things you studied, conductors, insulators. After that you came to a little bit about charges, then you came to potential difference, then you came to potential at a point. इतना कुछ हाँ बोलते जाओ.
मैं बोल रहा था आप कुछ करंट का बता रहे थे ना कि ऑपोजिट डायरेक्शन में.
हाँ, that you'll study when you study current. We'll tell you. Then you studied about a voltmeter, and in voltmeter you typically studied features. Okay, then connection mode. Again, have a look at these things. If you feel there is anything to ask, please ask. अगर आपको and you will ask why you all are unable to ask, shall I tell you honest thing? Because you all are not revising the content before attending the class. Touch your heart and say how many of you revised the last class content before coming to this class. The answer will be no. So my question is, sir, there was class test, sir, there was this, sir, we had girlfriend's birthday, sir, girlfriend's boyfriend's birthday who kicked me out. We are studying physics. What is the day today? Wednesday. Wednesday. Hold on. Wednesday. We study next physics next Wednesday. Some parents tell me, sir, one class a week is sufficient. Now my answer to all those parents is, when I am giving 8 days also, your child does not study and come. How about if I make more physics classes in between? Then your child will throw acid on me. 8 दिन में आप लोग नहीं पढ़ के आते हैं. If you don't study and come, you will not understand. There are two ways. Look, when I was at your age, my passion was electricals and electronics. So this chapter comes naturally okay to me. Like I may not be good in heat, but when it comes to electricals, this is my very strong part. I love it. You know me, okay? You have seen me. I love it. I used to love it not from your age, right from grade 5 and 4. I knew what is a resistor, how to work with multimeters just by going to shops and all. So if you don't have that basic knowledge, then you at least study and come. Otherwise, whatever I am saying, you are only attending to copy down notes. Your brain is not thinking to ask questions. Why? Because you have not read the previous content. And I also don't start policing you. If I now make a 15 minutes question answer session, okay, tell me what is charge. Tell me what about this. Then what is the best thing? Sir, anyways, we keep our mouth mum. If you ask us, we will put our head down and keep mum. After 10 minutes, you automatically will get irritated and you will start teaching. So then my question is, in the month of March, will I be sitting for the exam or will you be sitting? You will be sitting. But sir, in that I will get 98%. Very good, get 98%. I will be more than happy. And keep on calling that chappal wala electrician in your house who comes and tells you, Saab, wo IC kharab ho gaya. And then you will put it on the tower WhatsApp forum. Hey guys, the chap just said our IC is bad. He is illiterate and he is making you dance, and you also dance. One day you won't be able to console your heart. I studied engineering, but I am not able to light one bulb in my house. So go back to Three Idiots story. You should have studied something else, not engineering. You ate one guy's seat and you proved unworthy for the nation. The nation cannot get any use out of you, right? Whichever country you are, maybe. As simple as that. I am very ruthless in that. If you study something, study in such a manner that if you have a brother who is 4 to 5 years younger to you and asks you a question 4 years from now, that brother or my dear sister, can you tell me what is a voltmeter? Oh yes, voltmeter, come, I'll tell you. Quadratic equation, come, I'll explain you. What will you say? Quadratic, You know, there was one idiot from Hyderabad, he used to eat our head every 7 o'clock, and my mother, I don't know, I never wanted to go to him. My mother pushed me, my dad pushed me, and he used to give these lectures. Hey, go and type on chat GPT. उतना ही कर ले. आजकल तो होमवर्क चैट जीपीटी से ही होता है. You do homework from, at least go to chat GPT before my class. How is a voltmeter connected? It will reply to you. But do that much only. That will make you ask questions. Otherwise, see, I also don't get the pleasure to teach because there's no question. It's like a monologue. So I can make these videos and put them, because you all anyway don't ask questions. So study from YouTube. Easy है ना? इतना इंटरेस्टिंग चीजें पढ़ रहे हो, मे बी आपको ये इंटरेस्टिंग नहीं लगता है. समटाइम्स लाइट इज इंटरेस्टिंग. सर, वी डोंट हैव क्वेश्चन इन लाइट आल्सो. वी डोंट हैव क्वेश्चन इन एपी आल्सो. ऑर्गेनिक केमिस्ट्री, नो सर, वी हैव नो क्वेश्चन. ओके, इनऑर्गेनिक, नो सर, वी हैव नो. मेटल, नॉन मेटल, नो सर, वी हैव नो क्वेश्चन. ऐसे करने से कैसे होता है? अब बड़ा साइलेंट है जनरली. स्लोली, आई डोंट नो, आफ्टर कोविड all the type of students we get, you all are all of same mum. We love to remain mum. Remain mum. A man cannot teach 1 hour continuously. At least have some talk. Sir, socializing skills, 0. Etiquette skills, 0. Studying, 0. Hey, you are supposed to teach physics. Why are you saying all these things? Because if you don't have these skills, art of conversation. So can you explain that once again? Why is this? Why doesn't this happen? Are science par rahe ho? Even if I teach you geography, you'll no. And after the class is over, close the copy and put it. Very good. Chalo. Enough of bhashan. Current. Electric current. Sab Latin aa raha hoga. I am 100%. You all are taking it only as Latin. You must not be understanding. Okay, electric current. So current, as we say, suppose you have a river like this, water flows down the river, right? And you have your swimming pool of your apartment. This is stagnant. Okay, so we say there is no current in the swimming pool of your apartment, whereas when you go to river, your mom and dad says, don't go, you will get washed away because there's a current. So in order for a current to happen, there should always be a potential difference. Obviously, if you see this point B and if you see this point A, this height is much high. Okay, this is at H height and this is at 0. So you find that there is a potential difference. The potential energy here is much more. Potential energy here is 0. So water flows down this way. Bring the same concept to electricity. If you have a point at a higher potential and if you have a point at a lower potential, a charge will flow through it. A charge flows through it. And the rate of flow of charge, rate means anything that's with time. Rate means anything that's with time. So I clean utensils. अच्छा, महीने का कितना लेते हो? How much do you take for a month? With time. And that will be called as my cleaning rate. My cleaning rate. So similarly, the rate of flow of charge. Let's say in a t time, Q amount of charge is flowing from a higher potential to a lower potential point. Got it? In t time, Q amount of water is flowing from higher potential to lower potential. Then the electric current is given by the ratio of Q over T. So what is electric current? Electric current is the rate of flow of charge. Now we need to make it a little bit more interesting. So let's say this is my conductor, something like silver, or it can be, this is a portion of a conductor, okay? And this is a portion of a conductor, and this is actually connected. This is, you just imagine that the circuits that we had made, I've just magnified one portion of the wire. This is the metallic wire. So inside the metallic wire we would have a section like this, and this is known as the cross section. Cross section means this marker pen, if I slice it like this and I try to show it to you in this way, you see a circular cross section. The thing that is a diaphragm or a membrane. So you want to count that in t time how many charges flow across this cross section. So rate of flow of charge across the cross section of a conductor. Why only conductor, sir? Because only a conductor conducts, is called electric current. Electric current is the ratio of charge over time. In blah blah time, how many charges swept past this particular cross section, across a cross section? So how do we define it? Now we need to give it a SI unit also. So what is how to get the SI unit? Charge is in coulomb, time is in second. In that case, electric current is denoted by the word with the letter I. Then this is known as ampere. A stands for ampere. Ampere. Now can you define what is 1 ampere? So we will say the current flowing through a conductor is said to be 1 ampere when a charge of 1 coulomb flows past this cross section in a time of 1 second. So हिंदी में बोले तो 1 सेकंड में अगर 1 कूलम एक क्रॉस सेक्शन को कंडक्टर में पार कर जाता है, then the electric current flowing through it is known as 1 ampere. So sometimes you say, you know, I've got an iPhone, my charger is 2 ampere. 2 ampere means 2 coulomb of charges flow past the cross section of your charger wire every 1 second. And the air conditioner, it is having running and consuming 16 amperes. 16 amperes means 16 coulomb of charges.
So 16 seconds में बस 16
1 सेकंड में यार ये देखना है, ये चीज देखने में क्या प्रॉब्लम हो रहा है? दिस इज अ मैथमेटिकल थिंग, नो फिजिक्स इज आउट हियर. Q over T. हमेशा क्या, you take 10 coulombs and you have recorded your data over 5 seconds. So what do you get? You get 2 coulomb per second. At the end of the day, when you divide by T, it will be always coming in 1 second only. Yes or no? If I divide it by T, ultimately the answer is coming per second only. Okay, I found 10 coulomb of charge going through in 5 seconds. So in 1 second, how many? 2 coulombs.
Sir,
Yes, sir.
एक question.
Yes.
तो जो basically जो batteries होते हैं, they supply us with charges.
A battery never doesn't. A battery gives you an electromotive force. We'll come to it a little bit more later. Roklo. A battery gives you electromotive force. In order to move this charge, why will the charge move? You look at this diagram. Why is this charge coming from here to there? So how do you expect in your circuit somebody has to maintain a higher potential and somebody has to maintain a lower potential? Battery's job is like that of a pump. It maintains higher potential at one side and lower potential at one side so that the charge keeps moving. There is no loss of charge. The same fellows are keeping on moving. That's an electromotive force pump. You have the same water which goes up to your tank. Who gave you the water? The same water is going. You introduced a pump to create a potential difference, and the pump is nothing like a person which is sucking. I'm sucking from here, so the water is coming to me, and it's the same water which is circulating. Ultimately, these are the electrons. The electrons cannot go out of the conductor. What you can do is that make them move more faster. That means the current is increasing. Right? So here we have to see 2 more concepts and then we will close. Not now. Is this much okay? Okay. Right. Now another question that you may get in your exams, and true or false, that you need to understand. Now, okay. When electric current was first conceptualized and thought about, the period was around 1600 so and so. That's when, the first time our friend who also became the US president. Okay, he was, how can I miss his name now? Benjamin Franklin. So Benjamin Franklin was actually flying kites, and he found out, there can be electricity, static electricity and all. So we are going back, we are going much back in late 1600s and say 1700s. By that time, electricity's concept was already developed, and people took it as a notion. Notion means something that you have already adopted. Like when a child is born in India and you want him to, you give a pen to the child for the first time or a pencil, parents will usually put the pen or a pencil on the right hand of the child. That does not mean the child is right-handed. You may find later the child is a left-handed. Right? So that's a notion. Like our notion says, when you spot a red light, you stop. When you see a green light, you start moving. If you do the opposite also, there won't be accidents. That on green you stop and on red you move. But the notion is different. So the notion was taken as that electric current, direction, but current is not a vector quantity, it's a scalar quantity. This direction is just to show. Electric current's direction is always from positive to negative.
Yes.
Right? This is the notion kept from 1700s. And books and all started to get printed with this particular notion. Till the time we discovered electrons. Something around that 1870 odd, when J.J. Thomson discovered electrons, and we found that electrons are negatively charged entities.
Yes.
And if you look in a conductor, then who is the charge carrier? The electron itself is the charge carrier. And we have defined that electric current is due to flow of charges over time, and the charges are what? Electrons. And if you look at electrons, they being negative, let's connect this now to a battery, to a cell. This is positive, this is negative. You tell me which side the electron should go, being a negative entity.
Actually, like this side.
The electron should go in this way. The electron will travel in this way because it's negative. It gets attracted towards the positive side. Now, this is a major contradiction to what our forefathers actually assumed and wrote books. So the question now comes, why they said electric current is always flows from positive to negative. But after electrons have been discovered, electrons are found as negative charge entity, and they will always move from negative to positive. Electrons don't move from positive to negative. So the question comes, either stick to this or adopt this. But the convention that was taken was, since everything followed this, people started to call them with two different names, okay? And people felt it easy to retain this concept, and this was named as the conventional direction of electric current. Okay, though we all know that this is not correct, and this was given the name of electron current. And henceforth, whatever you are going to study, electron current concept dies here itself. From here, if you even study electronics engineering, you will go by this method only. All circuit diagrams universally, worldwide, everything about electricity is with this concept.
Why don't you use electron current?
अरे बोला ना तुमको, from age old days it has been practiced that when a child is born, give a red pen to him on the right hand. If a newlywed girl is coming to my house, step into the house with the right leg. Sir, if I step with the left leg, what will happen? Heavens don't fall. But there will be 50 aunties who will look at you and say, oh, ye bahu to kaisi hai. So we don't want that to happen. That's a notion. Books have been printed. Models have been designed. Formulas have worked out. So either you go back and do everything again, or you follow with this and you stop this concept. We stopped this concept. So if anybody tells you, what is the conventional direction of electric current? Positive to negative. Actually, how does the charges move? Negative to positive, and that is known as electron current. This is not wrong. The only thing is that we became stepmotherly and we don't study this any further. All studies are based on this. This just make it clear. So the direction of electric current is always taken from positive to negative. So based on that, if I remake my torch diagram and I add cells in this manner, my electric current direction will always be like this. That is from positive to negative. Hence on, we will not discuss even in grade 11, 12 and all. Again, when you go to 12, you will get a small portion, conventional direction and electron current. That's all. That is that one paragraph you will study. After that, no. All the circuit diagrams that we make, all the projects that we make, or anything that we design is based on this concept, which is that electric current flows from positive to negative. Our next class, we will be discussing about how to measure electric current, what is the device, how is the device connected, what is the speciality of the device.